Hello, Math 2. This is Mrs. Bricky, and this video is for Unit 9, Lesson 2, just Part B, multiplying. So if you didn't watch about adding and subtracting yet, watch that video first. This one is all about multiplying complex numbers. So when you're multiplying imaginary numbers together, it follows the same rules as monomials, but simplifying your answer is slightly different. We got to report our answer in standard form, a plus bi, and your answer cannot contain any higher powers of I. For example, your answer can't have an I squared in it. Anytime I squared shows up in your expression, you need to remember that I squared is equivalent to -1. So you can substitute a -1 into your expression for I squared. So here's 3 little examples of multiplying these sort of imaginary monomial sort of terms with only one term. So -3 multiplied by 6i is just going to give us -18i. So that one, we don't have to do anything fancy to change because it's just an imaginary number, -18i. So the next one is 5i times -7i. So this would be -35i squared. So in this case, we do need to do some modification because we cannot leave an I squared in our answer. So the -35 is here, but instead of multiplying it by I squared, I'm going to take that I squared, and remember that it's -1, I can substitute a -1 here. So this is the same as -35 multiplied by -1. And remember, that's a multiplying relationship right there. So it's not subtract 1, it's multiply by -1. So our final answer would be 35. Okay, and then the last one is a 2i that's being squared. So remember that squaring means multiply it by itself. So this is the same as 2i multiplied by 2i. So that's 4i squared. And remember that I squared is the same as -1. So we can substitute a -1 there. So that is a 4 multiplied by a -1, which is -4. When you're multiplying with complex numbers, complex numbers often have these two terms, the real and the imaginary term. So multiplying complex numbers is similar to multiplying with binomials. You have to do some distribution. You may have to distribute once, like in these two examples, or we may have to distribute two terms, like in these two examples. So, and same as before, we want to make sure that we don't leave an I squared in our answer, because I squared is actually a real number, -1, and so we can do a substitution there. So let's do some distribution here. So we multiply the 4 by the 5 to get 20, and we multiply the 4 by a -2i to get a -8i. And that answer is in standard form. We have the real part first and the imaginary part second. So that answer looks great, and we are done. All right, on this one, we're multiplying this complex number 3 plus 7i by 2i. So we distribute the 2i, and we end up with 6i as our first term. And now we multiply that 2i by 7i. So 2i multiplied by 7i is 14i squared. Remember that I squared is equivalent to -1. So this is 6i plus 14 multiplied by a -1. And that is just a -14 over there on the end. And then finally, that is not quite our finished answer because it is not in standard form. For standard form, we want that real part to come first and the imaginary part to come second. So our final answer would be -14 plus 6i. Okay, so now it gets a little trickier because we've got two terms multiplied by two terms. So just remember that that means that you need to distribute both the 5 in this expression and the 2i. So we're going to distribute both of those. I'm going to start by distributing the 5. 5 times 6 is 30, and 5 times -4i is -20i. So now I also need to distribute the 2i. So the 2i multiplied by 6 gives me 12i, and the 2i multiplied by 4i gives me negative 8i squared. And make sure you don't miss that squared. If you're multiplying a number with an I by another number with an I, you're going to have an I squared. Okay, so we've got all these terms, and we know our final answer needs to look like a number plus an imaginary number. We need to put it into standard form. So we need to first see that I squared and remember that I squared is equivalent to a negative 1. Not in this case subtracting 1, but multiplying by negative 1. So we've got 30 minus 20i plus 12i, and if that I squared is equivalent to a negative 1, this term becomes a positive 8. Okay, so now we just need to sort of scan through our terms, identify all of the real terms. So we've got a 30 and an 8 for a total of 38. And then in this case, if we look at our imaginary parts, we've got a negative 20 and a positive 12. So that adds up to a negative 8i. So now we have that answer in standard form. Our real part is 38 and our imaginary part is negative 8i. And let's try that one more time because it is good to practice and get the hang of it. So 3 times 7 is 21. 3 times negative 5i is negative 15i. Negative I times 7 is negative 7i. And negative I times negative 5i is a positive 5i squared. That I squared at the end is the same as negative 1. So this term is actually going to be a negative 5. So we've got a 21, a negative 15i, a negative 7i, and a negative 5. So if we combine our real terms together, the real terms are the 21 and the negative 5. So that gives me a total of 16 real. And the imaginary part is a negative 15 and a negative 7. So that gives me negative 22i. Whoops, that's not my best handwriting. I'm sorry. All right, so that's our answer in standard form. Okay, a little bit more, just 2 more examples that are similar but a slight variation. We've got 2 plus 3i squared. So whenever you see squared, remember that just means that thing is timesing by itself. So we've got 2 plus 3i multiplied by 2 plus 3i. So this is really no different than the ones we've been doing. You just need to realize that that means we have 2 plus 3i's that we're multiplying together. So this multiplies to give me a 4, a positive 6i. Now we're going to multiply and distribute the 3i. So 3i times 2 is another 6i. And then finally, we have a 3i multiplied by a 3i. That's a plus 9i squared. So that I squared is the same as a negative 1. So we've got a 9 multiplied by a negative 1. So that makes this ending term a negative 9. So we've got a 4 and a negative 9 for our real part. And our imaginary part is a couple of 6i's. So the 4 minus 9 gives me negative 5. And our imaginary part is a 12i. Okay, on this one, I've got a 5i that is squared. Well, that just means I've got a 5i multiplied by another 5i. And then I also have a 7i to the third over here. So I'm going to first work with the 5i's for just a second, and then I'll also include this 7i to the third. So 5i multiplied by 5i is 25i squared. The I squared is the same as multiplying by a negative 1. So this is negative 25 multiplied by 7i to the third. We can go ahead and multiply the negative 25 and the 7 together. That gives us negative 175. The I to the third is a little tricky because it's a higher power of I. But remember, that just means that we have I times I times I. So I could think of it as an I squared with another I as well. That's the same as I to the third. So this I squared, we could also think about as being a -1. And if we multiply -175 by -1, we get positive 175. And then I still have this little I over here by itself. So my final answer would be 175i. All right, last thing. Sometimes when I start showing kids how to multiply complex numbers, they forget how to add and subtract. So, strangely enough, I want to go back to thinking about subtraction for a minute so that you can remember how adding and subtracting works now that you've learned how to multiply. So this says fill in the blanks to make a true statement. We have some missing real part, minus 3i, subtract 15 and it's missing its imaginary part, but we know when we subtract those two things, we get 7 minus 12i. So we're going to focus on the real part first. So this is a real part, a real part, and a real part. You could even write a separate real part equation if you want. So something minus, don't forget the minus, 15 gives me 7. So if it helps you, you can kind of like write this out, or you can just think it in your head. Some missing real number minus 15 gives me 7. Well, that missing real number is a 22. If you write it out this way, you could see that what you need to do is add 15, or you might have already just figured that out by thinking through it mentally. Okay, so then we want to switch to thinking about the imaginary part. We've got a negative 3i, and we're subtracting, don't lose that minus symbol there, something to get a negative 12i. So if I sort of wrote out an imaginary equation here, it would be negative 3i minus something I gives me negative 12i. So that mystery number is a 9, because negative 3 minus 9 gives me negative 12. And if you were working on an equation or using an equation to help you, you might think about adding that 3i to get your answer. I guess maybe the tricky thing here is that the negative, we do need a negative 9, but the negative is over here. Okay, next mystery equation. It says here are two complex numbers with an unknown difference. So we've got a number minus a mystery number. So first part says if the result of this subtraction is a real number, which means that it has a 0i part, what could that second complex number be? Well, if we have our answer that's a real number, then the main thing that we need to happen is we need a number here, an imaginary part right here, so that it cancels out. So I need to have a 4 there for sure. So 4i minus 4i gives me 0i. And the other part, the real part, could be whatever you want it to be. It could be a 6 if you wanted it to be. So that would give me the answer 4, and then it would be plus 0i, which is just the real number 4. So you could have put any number you wanted in place of that 6 to get a real number. Okay, second part says if the result of this subtraction is an imaginary number, like a pure imaginary number with 0 real part, what could that second complex number be? Well, let's think about it. 10 plus 4i, and we're going to subtract something, and we want to get a 0 real part plus some imaginary part. Well, to get that 0 real part, I need a 10 right here. And this other imaginary part could be anything besides 4. Now, it can't be 4 because that would just give me the answer 0, which is a real number. So I could have maybe a 6i here. That would work. And then that would give me the answer negative 2i, which is an imaginary number. Okay, that is it for today. Here are a couple of answers for 19 through 27 on your worksheet if you want to work on those, and you can check yourself as you go. Let me or your teacher know if you have any questions. Thanks a lot.